Hello dear friends, welcome to MACSGATE. In today's session, we discuss about data types and variables in Python. Of course, it is part 1. We have some more sessions on this data types and variables in Python. Okay, so let us start with data types and variables in Python. Before starting the session, let me tell you, there are some recorded sessions already available in MACSGATE YouTube channel. You can go through those topics. Around 12 sessions already completed, which are basics. See, even if you not followed those sessions, you can continue today's session because Python is a very simple language. You can easily understand if you follow any particular class. Okay. So it is one of the easiest language. Okay. So let me start with, data types and variables in Python. The first concept which I want to introduce is object. Dear friends, in Python, everything you work with is an object. Everything, okay, you work with is an object. And classes are blueprints to create these objects. Actually, classes encapsulates data and their functionality. And your object is an instance of class. See, everything when I say, whether you take a number or you take a sequence or you take a container, anything you take, or you take a function or you take a class, everything in Python is an object. Okay, so please note that point. Let us continue further. See, there is a function called type function. The type function helps you to determine the class of an object. See, for example, if I take an integer object, I can find type of an object, type of this integer object. So it is of the class int. So this a which I defined is an object of integer class. It is an instance of integer class. Now suppose I take a function. Let me define a function. Okay, I don't do any work in this. I'll just write pass here. Okay, now I want to know the type of this. Print type of this function. And it is of class function. So it is an object of function class. Everything in Python is an object. Let it be a variable, or let it be a number, let it be a function, let it be a class. Everything in Python is an object. Okay, so please note that particular point, my dear friends. Now for this particular object, there are 3 important fundamental attributes. One is identity, which is unique identifier. So in C Python implementation, this unique identifier is memory address. Type defines its behavior. See, when I say type, if it is a data, it is data type. If it is a function, it is a function type. If it is a class, it is a class type. So this type defines the behavior of that particular type, whether it is data type, function type, class type, or whatever it is. Okay. Then value is actual data stored or represented in the object. So what I do is I take a small example here. I take a very small example here. Suppose you take literal 15. Even this is an object. So this particular object is having a value which is 15, and this will be having an identifier which is the memory address, maybe some memory address, I'll show you that. Then it is also having a type. It is integer type. So let us see this. Look at this. Now I am having number 15. So I just want to know what is the value of 15. Value, you know, it is 15 only. I want to know type of 15. I want to know type of 15. It is integer type. If you print, then you know that it is, if you print it, then you know it is of class integer. Am I clear? So you know type. Then what you do is you try to print its ID. You try to print its ID, which is the memory address associated with it. So this is the address. So as I mentioned, it is having an ID. What is the ID here? What is the ID here? This big integer address. Okay, like that. So I just write 240 here. So this is 240. I am writing only last three numbers or 3 digits. Here I am writing. Am I clear? So this is about ID. So every object will have a value. Every object is having an ID, and every object is having a type. Okay. So when you are talking about data type, so you know what type of data is it. Is it integer type, float type, bool type, or is it a sequence? Okay, or is it a tuple or set or whatever it is. Suppose if it is a function, you know that it is a function type. If it is a class, it is a type of type. So a class, that particular type is type. Like that you understand for everything. So for every object, we are having some value. That is what is stored or what is actually stored in that particular object. And ID is the memory address, whereas the type is the type of the object. Please note that. Okay. Now I just elaborate these 3 attributes. That is value. Value you already understand. Value is the actual data stored or represented in the object. Whereas identity means what? In Python, every object has a unique identity which is represented by a memory address. In C Python implementation, it is memory address. Maybe in a different implementation, this may be a different unique identifier, but we are talking about C Python default implementation. Generally, this identifier is the memory address of the object. And as we already used, the ID function helps you to determine the identity of an object. And one more very important thing, okay, you may be understanding it little later, my dear friends. Okay, that is, this identity is constant for lifetime. That is, the memory address allocated to that particular object is for lifetime. Okay, and regardless of what type of object is that, we will try to talk about this mutable and immutable objects. Whether it is mutable object or immutable object, the identity is constant for lifetime. So for an object, that identity remains the same. Okay, please note that point. That is one of the important points. We'll try to explore this. The memory model we try to understand so that you can do better programming in Python. Then comes type. Type defines how the object behaves, its characteristics and operations that can be performed on it. See, we are generally talk about, you know, data types. So for data types, what you will be having, sir? For data types, when you talk about data types, what is a data type? Okay, a data type is having objects and operations on the objects. You can say objects or values and operations on those values. Similarly, if it is a different type, even that particular will be having some attributes, properties and the behavior. Okay, so that is what it is. Please try to understand. So type actually defines how the object behaves, its characteristics and operations that can be performed on that particular type. See, when you are talking about object, here we are talking in a general sense. Okay, this object can be data object, or it can be function object, or it can be class object, or it can be any object. For every object we are having these 3 fundamental attributes. Please note that. Okay, now comes the most interesting part, that is variable. Dear friends, in Python This is very, very interesting part, sir. In Python, a variable is just a name that refers to a specific object in the memory. See, variable is just a reference. Just a reference. See, in C language, if you see, when you say variable means it is a allocated a memory address, but here variable is just a reference. Just a reference. Variable name can be any valid identifier. Identifier rules, you know it. Okay, we can use underscore, letters and digits. It cannot start with a digit. Underscore, if it starts with, that is special type of identifier. So just remember that particular idea about the identifier. Variable name can be any valid identifier. Okay, see, what you need to understand here is, when you take a variable and you say a is equal to 10, here a is not an object. A is just a reference to object. Here a is reference to object. See, always remember this 10 is the object, a is not the object. Okay, this 10 is your object which is having a value, type and identifier, and a actually refers to this particular one. But when you write id of a, it will give you id of this particular object. It will give you id, identifier of this particular object. So this is what we call it as name binding. Okay, this is what we call it as name binding. Okay, please note that. See, when a value is assigned to a variable in Python, the variable becomes a reference to a specific object in the memory. Reference to that particular, memory address. Okay, this concept is known as name binding. So let us see here. For example, if I say a is equal to 10, here 10 is the object. Am I clear? And you can see id of a. What is id of a? And you can see id of 10. Okay, let us see id of a and id of 10. Let us see. Let us print both of them. Let us print id of a and id of 10. This is id of a, and let us print id of 10. Both represent the same. Actually, here a is just a reference to that particular object. So when a value is assigned to a variable in Python, so it is called name binding. So for that particular object, we are binding some name. Okay, so this name, that variable name, is just a reference to that particular object. So when a value is assigned to a variable in Python, the variable becomes a reference. The variable becomes a reference to a specific object in the memory. Please note that point. This is very important point to be noted. Got it? Now the most important part, that is dynamic typing in Python. See, my dear friends, if you are aware of your C language or any other programming languages, okay, if you are aware of your C language or any other programming languages, if you want to define a variable, you have to mention the type, then you have to say a. So this is how we define the variable. Then you can assign the values to this particular a in C language or in C++ also. Okay. Now if you observe, in Python, you can directly create a variable like this. That is, we can directly create a reference to a object. We can directly create a reference to object, and based on this number value, the type is decided at runtime. The type is decided at runtime. You don't have to explicitly mention the type of the object. Okay, so that is the most important part in Python. That is what we call it as dynamic typing in Python. See, many languages such as C, Hash or Java, C, C++ require you to declare variable types, but not in Python. So in Python, we are having dynamic typing. What is dynamic typing? The type of variable is not declared explicitly. We don't have to mention. Of course, there is something called annotations, where you can mention if you want. I'll show you that, but that is not required. Okay, the type of the variable is not declared explicitly. The type of variable is determined at runtime based on the value assigned to it. So when you say a is equal to 10, when you say a is equal to 10, based on the value 10 is an integer. So what happens? This a is integer variable. Suppose if I say a is equal to 10.5, based on the value, now a is what? Float variable, and this type can be changed. Suppose initially you given say, okay, let me clear this and show you. Suppose initially you given say a is equal to 10, and later on you given 10.5. Now 10.5, a is referring to a float variable, or a is referring to a float object. So it is a float variable. A becomes a float variable. Is that clear? Please note that point, my dear friends. So these are the important points. The type of variable is not declared explicitly. The type of variable is determined at runtime based on the value assigned to it. And the type of variable can change over time as new values are assigned to it. So once you assign a new value to it, the type can be changed. Okay. So if you observe the key differences between dynamic typing, which we use in Python, and static typing, which we use in C#, Java, C++. Okay, if you observe, type declaration is not required in Python. That is, when it is a dynamically typed language, we don't have to explicitly mention that it is an integer type, float type, char type. Nothing need to be mentioned. Of course, in Python there is no char type. Okay, bool type, complex type, okay, list type, tuple type, you don't have to mention anything. But in static typing, it is required. In static typing, it is required. We need to mention that it is integer type, it is float type. You have to mention explicitly. Then type checking. See, what is this particular variable? Which type is this particular variable is checked at runtime in dynamic typing. It is checked only at runtime. Because of that, it can change its type during the runtime also. But in static typing languages, it happens at compile time. The type is fixed at compile time itself. Then flexibility. So here we are having greater flexibility when it is dynamic typing, because you can change the type of the variable. You don't have to fix anything. Flexible. You are flexible to change the types of the variables. But the flexibility comparatively less in static typing. Error prevention. See, this is the biggest problem. Dynamic typing looks great up to here, but error prevention is not that good with dynamic typing. Okay, because you may not remember what is that particular, because you not mention the type of the variable. Suppose later on you not remember what type is it, you may do a wrong operation on that particular type. That errors may be possible with dynamic typing. So you may be applying a wrong operation on that particular variable. Okay, but error prevention is more with static typing, because you know it is an integer type, so that particular things are very much fixed with the static typing. Advantage when you take for dynamic typing: flexibility. Second thing is concise and faster coding, because you don't have to mention the type of the data. Okay, anything, you don't have to mention the types and everything. So obviously the code becomes smaller. Not only this, there are some other advantage or some other features. Because of that, automatically the code size becomes very small in Python. Whereas in statically typing, the code size may be more, but readability of code is better in static typing. Here you don't mention the type of the variable, so code readability is not that good. But what they mention is use comments, doc strings to improve the code readability. Is that clear? So that is the idea. And one more very interesting thing is multiple reference to an object. Object can shared by multiple variables. Single object can be shared by multiple variables. So let me show you this. See, for example, A is referring to 10. That is, when you say A is equal to 10, A is referring to the object 10. Okay. Now when you say B is equal to A, no new object is created. This also refers to same object. Now if you say C is equal to A or B, C also refers to same object. Okay. So everything is referring to the same object. That is the basic idea here. So multiple references for the same object can be created. So that is the point to be noted. So if you want, you can check all these. If you check the ID of each of those variables, ID of A, if you see what is ID of A, I am taking last 4 digit, that is 7080. Let us take ID of B, same ID. ID of C, same ID. That is, all these variables are referring to the same object. All these variables are referring to the same object. That is the point to be noted. And of course, there is one very interesting, this is a syntactical part. Multiple assignments can be done. Okay, here first of all you see, suppose A is 10, so A becomes integer object. Now B is equal to 23.5, so B is a float variable. That is, it is referring to the float object. C is equal to Raju, means what? It is referring to a string. Okay, it is referring to a string. That is, it is a string variable. So instead of writing these 3 variables in 3 separate lines, you can have multiple assignments in the same line. Now look at this, sir. Here they are not of same type. They are of different type, but by the order, A is assigned 10, B is assigned 23.5 and C is assigned Raju. Now if you take C language, you can have multiple assignments or multiple definitions in the same line, but for the same type. But here you can do multiple assignments in the same line for different types also. That is a more advantageous. Of course, generally avoid such type of multiple assignments whenever it is possible. Okay, so that your code readability is improved. But this facility is there. See, there are certain things called facilities available in the language, but there are certain things called, programming practices, good programming practices. Am I clear? Which improves the code readability. That is the idea. And suppose you want A is equal to B is equal to C is equal to 15. So instead of saying A is equal to 15, then B is equal to A, C is equal to A, or instead of saying C is equal to 15, then B is equal to C, then A is equal to B, you can do at a time. Okay, so this also can be done. Even in this case, you can see ID of A. Even you can see ID of A 240. Then let us see ID of B. They all refer to the same object. Same thing, ID of C also you can check. They all refer to the same object. Is this idea clear? So this is about multiple assignments, right? So I'll just quickly recap what I discussed so far. Okay, I'll just quickly recap what I discussed so far. See, in Python, everything is object. In Python, everything is object. And this object is having 3 important attributes. One is value, the second one is type, and the third one is ID. So using type function, you can find the type of the object. Okay, if it is a data type, whether it is integer type, float type, list type, tuple type, set type, you can identify. If it is a function type, you can find type of it is a function type. If it is a class type, the type will be type. Okay, so please note that. And ID means unique identifier. Generally it is the memory address. So using ID function, you can identify the ID of that particular function. So we talked about ID, we talked about object. Object is what? Actually it is instance of a class. Okay, so class is a general thing which encapsulates the data and the functionality, and object is a type. Object is a type of that object is an instance of that particular class. So because of that, using type, you can identify this object belongs to which class. So classes are like blueprints. where objects are like a specific object or real world entities. Like that we can understand. See, these concepts are actually based on the object oriented programming, but don't worry too much about it, sir. Okay, so the internal internal story of the Python is object oriented only, but when you see the programming, it looks like a very regular procedural program. So you can use Python for procedural programming or object oriented programming also. Okay, when you understand the basic programming concept, once you complete all the basic programming ideas, you can talk about that object oriented programming. But this is what we need to understand, because everything in Python is an object. What is an object? It is an instance of a class. That you need to understand. Okay, so that is what we talked about, and using this we can identify, like using type function, we can identify the type of the object. Using id, we can find out the address of the object. That is the point. Am I clear? So far we just discussed about that, my dear friend, nothing more than that. And in Python we are having this dynamic typing. Dynamic typing means what, sir? The type of variable is not declared explicitly. Depending on the value, the type is decided. Okay, you don't have to explicitly mention the type of the object. Okay, but there is one point which I want to mention, like just let me go down. Or I think it is, there is something called attributes which can be given, like I think a int 5, something like this we have. I didn't remember, but So here you see, I am mentioning a is of type integer here. Here I am mentioning a is of type integer. It can be done. You can mention if you want. There is nothing wrong in it. Am I clear? Type can be associated. Am I clear? Type can be associated. So we are calling it as attributing the values or attributing the types for a variable. That can be done, sir, but that is not required for Python. Please note that. Okay, now we get back to this particular concept called data types in Python. See, when I say type, please note in Python, when I say type in Python, we have data types, we have function types, we have class types, like that. So far we are talking about general story of object, because when you talk about object, it can be data object, it can be function object, it can be class object, anything. Okay, but now we are talking about objects, data objects, and we are talking about data types. Okay, so the types which are associated with the data. Okay, data types. Okay, let us continue with the data types, my dear friends. Let us continue with data types. Data types in Python. See, this is the broad classification of data types in Python. This is a broad classification of data types in Python. So you can classify the data types in Python like this. One second. Okay, yeah. This is a broad classification, my dear friends. You can see. So we can classify them as, built-in data types or fundamental data types. The user defined data type, that is, if you are or you require a particular type of data type for your requirement, you can create it. But generally in Python, the built-in data types are sufficient for most of the purposes. Okay, but you can create your own user defined data types also. Okay, we have built-in data types which can be classified as scalars, non-scalars, that is single values, composite values. And total this built-in data types, some people also call them as fundamental data types. One second, sir. Moving of this is troubling me. Yeah. See, fundamental data types are the basic building blocks in Python that represent various kinds of data. And totally we are having 14 fundamental or built-in data types. Total 14 data types you are having. Okay, which can be classified like this. So this is another classification, sir. So generally people give different types of classification, but I find this classification better or most proper classification. So the built-in data types can be classified as scalars, that is single types. Generally some people call them as numbers. The scalars, they call them as numbers, and non-scalars, that is the composite types, or we can call them as containers. We can call them as containers. Is that clear? Now the scalars, today we are going to talk about the scalars only. Okay, these scalars can be classified as numbers and none. None is a special data type which tells you the absence of the value. So we are having integer type, float type. See, this complex is very special data type. It's not available in most of the other languages, but it is available in Python. Complex means what, sir? Complex generally means complex number. Generally it is used for, you know, scientific applications. Okay, then we have this bool data type, true or false. Okay, like that. So these are your scalar data types. Numbers, which are 4, that is int, float, complex and bool. And there is one special data type called none. So those are the scalar types. And non-scalar types, you can call them as containers or composite types. So under this we classify them basically like sequences, mappings and sets. Under sequences we are having string, list, tuple. Of course this range is a special type of sequence, we'll discuss it. Then we have bytes and byte arrays. So these are the sequence type. Then we have mappings like dictionary data type. Then under set we have set and frozen set. So these are totally 14 data types you are having, sir. So here 4 plus 1, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So totally we are having 14 data types. So if you want to be well versed with Python, first of all you should be well versed with all these 14 data types. So here first of all what we talk in today's session, we mainly talk about this scalars. Then we try to give a overview of this some of these data, what do you call this? We actually call them as data structures. Actually some of these are like, you know, data structures. We call them as built-in data structures also. Okay, so we give overview of all these container types. Then later on we have a separate session on strings, separate session on list, separate session on tuple, dictionary and sets, because we need to explore these types and the methods on those types to be explored in more detailed manner. Am I clear? So here in this particular data types and variables in Python, part 1, part 2, maybe part 3, depending on the time duration or depending on your interest, we try to give overview of all these types now. Later on we have separate session on built-in data structures. Okay, so where we discuss more detailedly about the string, list, tuple and dictionary and set, because for examination point of view, let it be GATE examination or your campus placement or anything, generally good questions they'll ask you from this built-in data structures. Whenever you talk about Python, the focus should be more on the built-in data structure, because you can expect questions from this built-in data structures. Okay, please note that. Here in this sessions, 1 or 2 sessions, where we try to give overview of all these data structures or all these data types. So here we are just considering them as data types, which are actually, some of them are actually data structures in some other language where you need to create them separately, or we need to use some libraries to use them. Okay, but in Python they are built in. That is the advantage. And one more important concept which we need to understand about this data types is, we are having 2 types here. One is called mutable, the other one is called immutable. See, what do you mean by mutable, my dear friends? If an object value can be modified, if you can modify the value of an object, it is mutable. The object is said to be mutable. See, out of 14 data types, only these 4 are mutable. Only these 4 are mutable. The list, dictionary, set and byte arrays. Remaining all objects are immutable. If the value cannot be modified, then the object is said to be immutable. So int, float, actually, you know, these numbers we call them, these fellows we call them as int, float, bool, complex and none. They are called scalars. All these scalars are immutable. Okay, please note it. And together with that we have the string, range, tuple, frozen set, byte. They are all immutable. Okay, the values cannot be changed. Don't worry about it. When I talk about each of these data type, I'll tell you about the concept of immutability. You understand better. For time being, what we need to understand means immutable means its value cannot be changed. Mutable means its value can be changed. That's it. That is the concept. And 3 important functions which we need to remember. One is print function. We already used many times. Type, which tells you the type of the object. ID, which tells you the identifier or the memory address associated with the object. Is that clear? So now let us talk about this scalars, one after the other. So from now onwards, it is more practical. So where we write the program and we try to understand this. Is that clear? Okay. So let us start from here. So this, what are the scalars? 4 numbers and 1 none. Int, float, complex, there is a printing mistake. So let me correct here itself. Complex, bool and none. These are the scalars and all the scalars are immutable. All the scalars are immutable. See, actually, you know, for reusing of the code and for, you know, performance purposes, if the objects are immutable, then it is better. Because of that, all the basic, data types or all the basic types are considered as immutable. Actually, the float and complex can be made mutable also. There is no problem. But at language level, they want, you know, all the basic fundamental types or all these scalar types to be immutable. So they made all of them as, immutable. Please note that point. Now let us start about integer. Integer. Just a minute. Oh, there's some problem here. Just 1 minute. So now let us talk about integer. See, numbers without decimal point are known as integer. Integral values are represented with integer data type. And in Python, integer data type is represented with int class. Okay. So here if you see, a is equal to 10. This is integer type. You can see type of a. So it is integer type. Okay, and one important thing which I want you to note here. Okay, see, if you see this particular ID, okay, the ID of a, if you see, ID of a is 7080, okay, to the end. Now what I do is I create another object whose value is 10. I create another object. See, I am not making B is equal to A. I am not trying to make B referencing to A. I am just creating another object, B is equal to 10. Obviously, B is integer type. Now I want to see ID of B. I want to see ID of B. What I do is I'll print both of them, then you will understand it better. I want to print ID of B. Let us see the ID of both. See, I am not assigning B equal to A, or not, I am not using the assignment operator here. I am just writing A is 10. I created A object or A integer variable. 10 is the object. A is referencing to 10 object. Now I am creating another variable B which is referring to 10. Now the doubt is, look at this. Here I created an object 10 and A is referring to 10. Now this is because A is equal to 10. Now I am having B is equal to 10. The doubt here is whether B will get a new object 10 and B is referring to 10, or A refers to 10 and B also refers to 10. This is the doubt. So for that, what I do is I'll check this. So let us run this code. If you observe, A and B are referring to the same object. Here A, B are referring to the same object. Both are referring to the same object. So if it is same value, we don't need to unnecessarily create a new object. So object is already there. So B also refers to the same object. But don't conclude anything. Please see here. Please see this here. I'll just copy this code. I'll just make changes. This time I take A is equal to 1000 and B is equal to 1000. One second. I take A is equal to 1000 and B is equal to 1000. So what do you assume here? A is 1000 and B is also 1000. So A is referring to 1000 and you assume that B is also referring to the same object because it happened here. That is what we assume. Okay, so let us check this. Let us run this. Oh, what happened? Now B is referring to a different object. B is referring to a different object. Is the idea clear? See why it is happening for 10, it is happening, but for this it is not happening. Here A is referring to object 1000, B is referring to a different object 1000. B is referring to a different object 1000. Please note this point, my dear friends. Please note this point. Here we call it as reusing of same object is possible only for certain object, or is defined, you can say. Is defined only for, okay, few objects, not for everyone. What are the objects for which you can do this reusing of the object? See, you can do it for numbers 0 to 255 or 256, because when Python interpreter starts, all these objects are created by default. All these objects are created by default. Okay, so whenever you have any of these numbers, the reusing of the object happens. But if you go beyond this range, the reusing may not happen. Please note that. See, the reusing of object is possible only for few objects. They are like, 0 to 255 or 256. Let us check this. Then for bool, true, false, okay, and none also you can say. And one more important thing, that is string. Today we are not talking about it. Even for string, always reusing of same object will happen. This is a very interesting one. For string, reusing of object happens always. Okay. For bool, always it happens. For bool, always it happens. Please note that. Okay, let us check this. Let me try this for 256. I think 256 or 255. Yeah, up to 256 it is there. Maybe 257. You see, that is different. They are not reused. See, some people say it's like, every object is reused. That won't happen for every object. For this, standard ones, which are started or created when the Python interpreter is created, for them, the same object is reused whenever it is possible. Please note this point. Is that clear? Now, this integer values can be expressed in following ways, like decimal form you can express, that is base 10, that is the regular one. You can express them in binary format. Okay. For example, A is equal to 10, that is decimal format. You can express them in binary format. Literal value should be prefixed with 0. Suppose you are writing that integer value in binary format, it should be prefixed with 0 capital B or small b. 0 capital B, small b. And binary format means only 0 1 can be used. So you can have 1 0 1 1, something like this. Then you can print it to check what is that value. Of course, whenever you print, what happens? It prints the decimal equivalent of that. But if you want the binary equivalent of that, you have a function called binary function which can be used so that you can get the binary equivalent. That is same number you are going to get. Is that clear? So whenever you print a number which is represented in any format or represented in any form, like binary form or octal form or hexadecimal form, when you print it, you always get the decimal form of the number. Please note that. Okay. For example, you take octal. For octal, you need to start with 0 O, capital O or small o. 0 O, you can write. Octal means what, sir? You can use only digits from 0 to 7. Okay, you can say 0 to 7, like 6, 7, 3, 3, 4, 5. Suppose if you write 8 here, it will be an error, because octal means 0 to 7 digits only you can use. You cannot use 8 here. Please note that. So this is the decimal equivalent of that octal number. Okay. So you can do something like this, sir. A is equal to in octal format. You can also write it in, hexadecimal format. Hexadecimal means 0 to 9, A, B, C, D, E, F, because A stands for 10, B stands for 11, and F stands for 15. So you can have A, B, C, D, E, F, something like this. Then you can get the decimal equivalent of that. So integer values can be expressed in regular, decimal format, base 10 system, base 2 system, base 8 system, or base 16 system. And but if you want to use them in any other system, you have to use appropriate prefix for them. You have to use appropriate prefix for them. Please note that. And we have this conversion functions, like, just now I told you binary, convert from binary, from any base to binary. Suppose you are having a number in, decimal format, 23. You can get, okay, here it is not the code, it is marked down. Let me remove this. Let me take a code here. So what happens? You get the binary equivalent of that. Now if you say oct, you get octal equivalent of that number. And if you do hex, you get hexadecimal equivalent of that number. You get hexadecimal equivalent of that particular number. So these are type conversion functions, like, base conversion, not type conversion. They are actually base conversion function. Very, very sorry for that. They are the base conversion functions. So from any base to binary format, you can convert. From any base to, octal format, you can convert. From any base to hexadecimal format, you can convert. Please note that. Then comes float. See, floating point number is a number with a decimal place. See, either you can write in decimal format, or you can, like, after decimal point will be there, or you can represent it in a scientific format. Okay. Floating point number values are represented with float data type. Using float data type, you can represent them, and they belongs to the class float class. Okay, let us see some examples for floating point numbers. Okay, float variable 10.345. Then you can see this is the float variable. You can see the type and ID of this. Type of float variable. What is the type? It is a float type. What is the ID of this? ID of float variable. You can find the address. Now, one important point here is, you create a float variable, always a new object is created. Okay, for float variables. So here for integer variable 0 to 256, same object is reused, but reusing of same object never happens for float variables. Of course, when you do float variable 2 is equal to float variable, when you do it, in this case what happens? ID of float variable 2. So it is 1456 now. So this is assignment. Even here what happens? You see it is creating completely different. Let me print these two and show you. So in this case what happens? Here, because we are saying FV2 to equal to FV, no problem, they refer to the same object. But whenever you write some FV2 is equal to same value, 10.345, and if you see the IDs, they are always different. So always a new object is created when you create a new float variable, my dear friends. But for integer variable, when you create a new integer variable, if it is referring to an object whose range is from 0 to 256, reusing of object will happen. But for float variable, whenever you create a new float variable, a new object is always created, even if it is equal also. Please note that. Okay. No reusing will happen for float variable. Then comes complex number. Okay. So complex number, A plus BJ form. Here it is very important. A can be any integer or real number, B can be any integer or real number, B should be there. Suppose if you write A plus J, that is syntax error, sir. I'll show you that. Here A and B contain integer or floating point values. Okay. Complex values are represented with complex data type, and they belongs to complex class. In real part, if you use int value, then we can specify either decimal, octal, binary or hexadecimal format. See, in place of A, if you are using integer, okay, that is real part we call it. In the real part, that is, if you are having a complex number, 5 plus 3j, this is integer, no? This integer part, then this can be represented in decimal form, binary form, octal form or hexadecimal form, no problem. That is what he is saying. Okay, but imaginary part should be specified only using decimal format. Imaginary format should be only specified in decimal format only. See, generally for basic understanding purpose only we require complex. Generally for scientific applications we require this particular complex type. Okay. Now let us see complex variable is equal to, see, as I told you, 5 plus j is illegal. 5 plus j is illegal. You should write 1j here. Suppose if I say 5 plus j, you see that error, j is not defined. But you write 5 plus 1j, it accepts. No problem. Please note that. Now if it is 5, in the binary format you can write. For example, integer, no, this can be written in binary format. Like, binary format means what? 0b, 0, 1. Okay, 5 means what, sir? 4 plus 1. Na? Okay, something like this. Let us try this. This is possible. Octal also you can write it. But here you cannot write binary, decimal or any other formats. Only decimal format you can use for imaginary part. Please note that point. Okay. And there is an alternate way of writing complex variables, sir. There's an alternate way. You can say like complex the real part and imaginary part you can write separately like this. That is also allowed. This is also allowed. This is also allowed. No problem. This is an alternate way of writing complex variable. Okay. And you can see the type of complex variable, 1 or 2, whatever it is. You can see that. What is the type? It is of type complex. You can find ID of this. Now for complex, the complex number is actually made up of 2 numbers. So for real part, you are having an address. For imaginary part also, we are having an address. Okay. It is like this. So whenever it is a complex number, complex variable, okay, so it is actually having 2 parts. One is real part, the other one is imaginary part. So real part is a different object, imaginary part is a different object. Okay. So please note that particular point, my dear friends. Okay. You can just get that ID of CV. You can get ID of CV real part. So this 8608 is the ID of CV, no? The real part ID is different. The imaginary part ID is different. The imaginary part ID is different. Oh, sorry. Somewhere. Imaginary. Okay. So you can check all of them. Print ID CV comma ID CV dot real ID CV dot imaginary. They are all different. So actually the story is like this. CV is referring to this object where you are having the 2 objects, 2 references, 2 either integer or real objects. So this is one object, this is another object. This is exactly what going to happen for complex number. Am I clear? Please note that. Then comes Boolean. Boolean values, that is true and false, are represented by bool data type. We can use bool data type to represent Boolean values. See here, for all the keywords, actually true, false, none are also keywords. All the keywords are written in lowercase, but you see true, false and none. So the leading letter is capital letter. So this is capital T. Always remember, it is capital T, true with capital T, false with capital F. Please remember. Internally, Python represents true as 1 and false as 0. In Python, bool data type is represented with bool class. Okay. And generally, this bool data type is mainly used, with conditional control flows. Mainly we use it for checking the conditions. We are going to mainly use it. Okay, bool variable. You can say true. Small t if you write, that is wrong, sir. True, don't ever write this. This is wrong. If you say, it says, what is this? True is not defined. Am I clear? Maybe if you want, you can say like, string, that is fine. It is a string, then it is a fine. Then it is fine, no problem. But true means capital T. When you want Boolean variable, it is capital T. Please note that. Am I clear? Please note that. You can see the type of Boolean variable. And you can see the ID of Boolean variable. The ID of Boolean variable is this. Now, what about ID of 1? So 1, but true means, internally true means 1 and false is 0, but ID of 1 and Boolean variable ID will be different. Please note that. Okay, that is the basic idea. Whenever you write true, it is Boolean variable. Of course, similarly you can try with false. Even that fellow will be having an ID. And generally this ID will be fixed itself throughout this programming, because when Python interpreter starts, all these IDs are created like true, false, the integer 0 to 256, string object. Whenever it is created, that that particular object is created, and that particular ID is created, and that ID can be reused for string. So reusing is possible for integer in the range 0 to 256, bool both true false, then none, and of course this particular fellow strings. Strings we talk about them tomorrow. Okay, please note that. And then comes none is a special constant that represents absence of the values. See, generally you want to here variables are references. Variables are references. So you want to initialize something with absence of the value, then you can use none. And for function arguments, if no arguments are passed, you can use none. For return values, you can use none. So for such special purposes, we are going to use this special variable called none, my dear friends. Please note that. Okay. Yeah. So this one I already mentioned, if you remember. Reusing same object is defined only for the following ranges: integer 0 to 256, bool is defined always, string always. Reusing same object is not defined for float and it is, please be careful, the spelling mistakes, float and complex. Please note this. Okay. If you are having any doubts, you can ask me. So this is about data types and variables. Today we discussed about in this particular data types and variables we talked about scalars, right? The scalars part we completed. Then in the next class we talk about the overview of the important data structures or containers. Actually we call them as built-in data structures. Actually we call them as built-in data structures. Am I clear? Like that. So in the next class, maybe tomorrow we'll have this, maybe a half an hour session, like strings we complete. Okay, we'll have discussion. I'll plan the sessions regularly, sir. Now Sudhakar sir is taking DBMS, so I'll be taking these sessions Python simultaneously. We'll try to cover most of the topics which are required for your data science and artificial intelligence, right? And I'm planning for this probability very soon. Okay, probability will be discussed very soon. Okay, maybe from Saturday only, Saturday Sunday I'll plan for this long sessions for probability. Okay, I'll please join my Telegram channel, CS_Sridhar. This is my Telegram channel. You can join my Telegram group for regular updates, my dear friends, or you can subscribe subscribe and press the bell icon so that you can get regular update about classes on MACSGATE. That's all for today. Thank you.